Hi guys, this is the referential guide to how to get started with FXGL. We've already done this on many occasions previously, but since then, FXGL has had quite a lot of changes in the public API and internally as well. So I decided to make a brand new tutorial to make sure that the videos are updated with the implementation of the library. And it also might be useful for new users of FXGL. So the latest version currently is 0.2, and yeah, so we'll proceed from there. There is a nice tutorial on libgdx, which is the sort of getting started guide for libgdx. And I thought it would be quite nice to have similar thing for FXGL as well. So today I'm going to pretty much clone um, the simple game that they use in the tutorial and try to make similar thing in FXGL. Right. The first thing you'll need to do is to create a new project. I'm not going to go over very sort of specific details of the steps because it is likely that some of you will be using a different IDE. So just create a new project. And in my case, I'm going to create new module. And I'm going to call it, what do they call it here? I think it's droplet or something. Drop. Okay, so I'm going to call it drop. And I'm going to add maven support. And you will need to do that too in your IDEs. There are plugins for Maven pretty much all major IDEs, so you should be fine. Maven is the easiest way to get FXGL into your project and basically use it to automatically build, compile, and get all your assets packaged properly, or just one command really. Right, we don't need this. I've also increased the font, by the way, so if you were having problems with reading it on the smaller screens, if you could just write some feedback whether it's acceptable now, because if I go any higher, it'll be very difficult for me to read because I'm quite close to the screen. Okay, so this is what you typically get for a basic Maven project. But because I already have created Maven PIM file, which is the project object model, I think, I'm just going to copy it over, which you can also do by going to FXGL games repository and just clicking on one of those, say POM, and then you can find POM file, which is that one. Because it's pretty much the same file that you'll use for most of your FXGL games, it's easier to just keep it somewhere. And all you need to do is pretty much replace group ID, artifact, and the version. And also, if you scroll down here, there will be a main class. So this is where you put your main class for it to be packaged in a standalone jar application, which is really nice because you can easily deploy your stuff. By deploy, I mean really just package it into a standalone executable and send to your friends or something. Right, so yeah, so I'm going to do this, that will stay the same. That will change to drop. So this is essentially the name of the jar that will be created. Version, I'm going to leave snapshot in there. I'm just going to put 0.1. Yeah, like I said, this is exactly the same stuff for most of your Maven projects. and some of you will be familiar with it anyway. So the stuff that actually gets FXGL into your project is that bit. So you specify the repositories, which is Jetpack. So this is where we can easily get code from GitHub. So it gets compiled there and then gets sent to you to be included in your maven project. And this is the dependency. And this is the name of the group, which is essentially my repo username. This is the name of the library that you're downloading, which is FXGL. And the version is 0.2.0. And don't forget to rewrite this as well, main class, when you actually have the class itself, which we're going to create just now. Also, this tutorial is probably going to be longer than usual ones, because typically I basically rush to get through quite a lot of code, because the stuff is usually complex in the tutorials. And this time we're doing an extremely simple game, so I'm going to be slower and try to explain every line of code as we go through. So irrespective of what IDE you're using, you should have something like this, because this is the standard maven directory structure. So source main Java, and in there we're going to create Java class called drop app, and this is going to extend our game application. Make sure that it imports correct game application, although there's probably just one of them anyway. And you will need to implement all those methods, and I like keeping settings at the top so you can easily see game settings. Also, you might want to define the main method, which is just that. So it's public static void main, and it should be within the drop app. Well, it typically is anyway, in which you simply launch as if you're launching a typical JavaFX application. Now, once we've done that, don't forget to come back here in your POM XML and change this to what you've just created. Actually, I should have created package first. So yeah, don't forget to create packages. It is going to be called just drop. Yeah. I'm going to move this into the package. It is going to be drop. Right, so it should have this package. There we go. Right, so drop, yep, and drop app as the main class. And now, just to make sure it's working, you could first of all try to run this from your IDE. We're going to disable intro, and we're also going to disable menus. So that should just run empty game, which it does. So we have essentially nothing on the screen except for the window itself. Now, if you open your command line and go to wherever your project sits, in my case it's workspace, FXGL games, go to drop. So in the top directory, you should be able to call maven package, considering that maven is actually installed and all the class paths are set properly. So that will essentially compile all your stuff, copy all of the resources, the assets, into the package jar, which should be available in the target class or target folder. So if I go to drop target, and this one is the original, which is just pure application source code compiled, and this one is the one that has everything packaged inside. So if I just double click this, it should run whatever you have created. So as you can see, it is really easy. So you have just one command that you need to remember, which is maven package. And from now on, you can do this for pretty much for all FXGL games that you create, as long as they're maven based. Right. So yeah, so that was that. Now we need to actually add some stuff in there. And I'm going to pretty much follow this tutorial that they've got. So the assets, yeah, these are the free assets that are provided as part of this tutorial, which I already downloaded, and they look like this. So there is one MP3 file, which I renamed to BGM, which stands for background music. Then you have a bucket, a texture for droplet, and drop sound, which I'm assuming is the one that is played when you catch those drops. So essentially the game idea is, yeah, catch raindrops with a bucket. And that should be enough to implement, right? So the first thing that they do is initialize various settings. In FXGL, this could be done in this method, which is called init settings, and which you should have overridden by default. By default, the values are 800 and 600 for width and height, but we can easily change them by just setting width to 800 and setting height to 480. Actually, it would be better if we did this the other way around, so you can see the difference easier. Yeah, so this is what the application looks like when you change width and height. Also, these values are target resolution, meaning it is what your game should look like in an ideal sort of resolution, if this resolution is supported. If it's not, then your application will be automatically scaled up or down. It shouldn't scale up, it'll most likely to be scaled down if the size, if your target resolution is higher than the physical screen can handle. The initialization or the configuring starter classes in FXGL is easier because FXGL doesn't support web and currently doesn't support mobile. I say currently because as soon as they introduce Java 8, full functionality of Java 8 on mobile, so we could potentially port FXGL using JavaFX ports, I think it's called, and one of the glue-on plugins that allow us to compile stuff to mobile. So that is a possibility in the future. Right, so we're going to skip the Android part and the web part. So straight into loading assets. All right, so once you've created your sort of boilerplate code, you should have a directory called resources because it is also standard directory layout set by Maven. In resources, you will need to create a directory called assets. It has to be exactly like this because this is how FXGL finds its internal assets. And in this folder, you'll then need to create each directory for various types of assets that you'll need. For this tutorial, we'll need textures. Also, make sure you don't introduce typos in the when you type these things. So it's resources. What was it? Source main resources. So yeah, you can either use your ID to create your directories, or you could just create them manually if you wanted to. So we have textures, and I want also sounds, because there is one sound that you can see, which is that one. So this is the drop sound. And we'll need also music. So we'll need to create a directory for that as well. So essentially all MP3 files should go under music, because they're supposed to be lengthy files that need to be streamed rather than completely loaded into memory. Then you have PNG files or JPEG files, which are textures in FXGL world, and you can place them under textures. WAV files, which are short sounds, or they're supposed to be, go under a directory called sounds, and this is where FXGL will be looking for them. So I'm just going to move these things over. So that is there. That goes under textures. And that goes under music. Right, so these are the files that we just copied into resources, so they should now be visible to FXGL when we load stuff. Okay, so yeah, next thing I suppose is to create droplets. Any object within FXGL so any game object is an entity, or game entity if you want. And we're going to create one game entity called droplet. Each entity is a normal entity within ECS, which is the entity component system. So each entity doesn't have any information about itself, except for components and controls. The game entity defines certain components that you're likely to use, but they're not limited to them, so you can create your own components if you wanted to. What we need right now is a position component, which we can use to specify certain coordinates where we are going to place our droplet. So if we want to place it at 100 and 100, so these are XY values, at this particular point, then this is how you would set values to the position component. And there are various other things you can do with other components as well. So bounding box component defines the bounding shape and the values that are used for computing collisions. Main view is where you set graphics for your entity. Type defines what kind of type an entity is. Could be type player, type bullet, or type droplet, which is in our case more sensible to use. Rotation defines the rotation in the world. So if you change rotation to something like 90 degrees, it'll be rotated, and main view component will be notified so that it could rotate its view as well. So currently it doesn't have anything, and we wanted to have view component of the texture, which is droplet. So we can just set view. We need to create new entity view, which will take our texture. But first, obviously, we need to load our texture. The class texture is essentially a wrapper around image view of JavaFX. So if you're familiar with that, you should be able to easily use texture. Droplet texture. So in init assets, for example, you could load your texture using asset manager, or what's it called, asset loader. So any asset that you need to load from this directory, which is internal assets, you could use an instance of asset loader, which you can obtain by just calling get asset loader. Alternatively, if you are not in the game application class, you can call one of the static methods to call to get a service. So you call game application dot get service, and then you pass in the type of the service that you want. Service type asset loader, which is exactly the same as get asset loader. It's just for global access within different classes. Get asset loader, load texture. So as you can see, there are a lot of load methods which load various things. So load texture loads a texture with given name from the directory called textures. And similarly, other things, sound, music, and various other asset types. Once it has been loaded, it will create an instance and we'll put it in the memory cache. Next time you load the same asset, if the cache hasn't been cleared, so if there are instances available, it will be loaded from cache from memory, so it'll be much faster. So it is kind of similar to how libgdx loads internal assets. In fact, some of the features of FXGL have been modeled off other engines or other game libraries. So that should be more or less familiar. So you obtain instance to get to asset loader, and then you load the texture by passing just the name of the texture without the assets or textures bit, just the name of the file. So this would have loaded the texture, which you then pass into entity view just like this. So this will create an entity view out of your texture and assign the view to main view component of droplet. Finally, you obtain game world. So all entities are handled by game world. Anything you need to do with an entity is likely to end up be done in the game world. So you obtain an instance to the game world, and you add an entity, which is the droplet. And as you can see, you can do various things, mainly queries, to obtain various sorts of entities. You can query entities by type, by layer, range. You can filter them. You can obtain by certain positions and things like that. Now, if we run this, this should create a droplet, set position value to 100 and 100, and assign droplet texture to the entity. So if we run this, we should ideally see droplet, which is that. All right, what else? But usually when you have more entities, you would typically create a class called entity factory, which will contain static methods, things like new new droplet. And then maybe you pass in things like position, so where to spawn the droplet. And we're going to copy this there. So the value now becomes x, y. We now need access to our asset loader, which will load statically, and we use game application like you've seen just now. So we obtain service type asset loader. So this static method basically means they will be loaded before any other method in this class. So we no longer need to do this. So this allows us to load assets somewhere else in this entity factory. And then we return droplet. So it'll be new entity view, asset loader, load texture, droplet PNG. In fact, I'm going to just do that so you can see better. So this will create our droplet at position XY, which we can do like this if we wanted to. Entity factory, new droplet, 50, 300, and add droplet to the game world. Yeah, so we've just placed this here. Now, what else we need? We need the bucket, and which we're going to do exactly the same. Public static entity new bucket. Again, we're going to give it some coordinates so that it will, when it will create the bucket, it will place it at XY. You can even copy the code because mostly it is very similar. To rename this to bucket and rename name of the file to bucket PNG. So it will load this from the textures and places X and Y to position to X and Y. Now we also need to be able to control the bucket. So if we, instead of droplet, we say new bucket and we'll place it get width. Get width is how you obtain this width, which is the target width. And by using this, you're pretty much getting away with easily changing this value whenever you want, so that this is not hard-coded. Get width divide by 2, and get height minus 100. So the XY coordinate system is, well, X is obviously from left to right, Y is from top to bottom. So Y, positive Y axis goes down. And there's our bucket. Now we need to be able to move the bucket. Actually, I'm just going to do that. In order to add some sort of behavior to an entity, you need to create control or an instance of a control, which you typically create your own and then extend one of the abstract controls. So it's a Java class that is going to be called bucket control, and we're going to extend abstract control. So what do we need to be able to do with a bucket? Pretty much just move left and right. So we're going to create a method for moving left and another one for moving right. And in order to do so, we need to obtain position component of the bucket, which we're going to call position. And we can do that when the control is being added to the entity. So that entity is going essentially to become the bucket. Or it could be any other entity. That's the nice thing about controls. So you can assign this control to a droplet. So you could then potentially move the droplet using these methods. So it is extremely flexible. Position, entity, get component. There's one for safe query or safe accessor, which returns optional if you don't know whether it's there or not. But we definitely know it's going to have position component, so we're using unsafe version. If you want to make sort of ensure it actually is there, you could create or add an annotation called required and place certain component, which is the position component, in there. When the control is being added to an entity, if this particular component isn't there, then you'll get an exception, which is a way of ensuring that it's going to be there. Right. Left is essentially moving. Right. First of all, we need to get speed. Double speed. Speed is going to equal to time per frame multiplied by, say, 200. This is typically the value that you should be able to get within a second. Maybe large a bit, we'll see. So left would move the position. Translate is essentially move along certain axes. So x is an axis to move along. Translate x minus speed. And same to right, except we're going to pass in plus speed. So positive. And that is essentially it for bucket control. We now need to define control first. I'm going to define it right there. Bucket control. So when we create new bucket, this is the entity factory which adds stuff into the entity. Add control, new bucket control. So that when we return, it will contains the control that we need. And once we've created the bucket, we can now assign our bucket control, initialize it by obtaining control and safe, because we know that it's going to be there. And this gives us bucket control, or instance of it. So the next thing would be input, because as it is now, there's nowhere we could define left and right. We've defined how to move the thing, but we haven't defined how to trigger a movement, which you can do via input in the init input method. These methods are called what they're called simply to have some sort of consistency across FXGL games. They're not in any way different, so they're essentially just methods. You can call them whatever you want, but using input stuff within init input makes a lot more sense, and it's a lot easier for other people to recognize this as well. Consistency is the key pretty much in software development. So yeah, there are two ways of adding actions or input mappings, and I'm going to use add action directly. And what you need to do is create an user action, and you can override a few things which are called an action begin, which is called when you just start pressing the key or mouse button. An action is called as long as the key is held, and an action end is called when you release the key. So what we need is on action, so that it is executed when we hold the key. Next thing is to give the name of the user action, to give it some sort of meaningful name, which is move left. There is some code that is going to be within onAction, and the next bit is to specify which key it should bind to. And you specify key code, and for left, I'll pick A. So A, when we press A, when we press and hold key A, we're going to move left. And I'm going to do move right exactly in the same fashion, but the key code is now D. So A moves it left, D moves it right. And that is essentially everything that we need for now. That should ideally work. Right, so A moves it left, D moves it right. And if you can see here, there's actually FPS shown, but it's using bright color, so it's on the right background, it's not really visible. But if you don't want to be shown, you can easily disable it in settings. Set show FPS false. Right, so now we have our bucket ready. The next thing is to spawn our droplets randomly. Rendering in libgdx and in most other game engines, libraries happens manually. In JavaFX and hence in FXGL, you cannot really render it manually. You could kind of draw manually on the canvas if you wanted to, but nodes in the scene graph are rendered automatically by JavaFX, so there's no need to worry about that. Also, the input that we've just done is slightly different to what you would typically do. This is done in the update. You simply check if a certain button is pressed. In FXGL, it's slightly high level, I'd say, because you're not saying if it is pressed or not, you're saying do this when it's pressed. So it's kind of reverse, slightly in a reverse way, so to speak. Yeah, so we've done the movement, and now we're going to add raindrops. We already have Entity Factory to spawn droplets. So what we need is a function or a method that is called every certain amount of time. And this can be done using master timer, which you can obtain in instance 2 using get master timer. Run at interval, you pass in the function to run, which I'm going to use a lambda for, and then you pass duration, say 1 second. This means that this code that you will write here in between those brackets will be executed every second. And this is essentially what we need. So entity, droplet, new droplet. We're going to use a random function, math.random, multiplied by get with minus, say, 64. They're using 64, so I'm guessing the width of the image is 64. And for y, let's just put 0. So it's going to spawn always at the top, but it will be randomly spawned in terms of x-axis. Finally, we call get game world and add entity droplet. So if we run this, that should spawn droplets every second. There we go. So they are being spawned, but they don't move. In order to add some behavior, like we already did to our bucket, we will need to create another control, which is droplet control, which again extends abstract control And in fact, most of this stuff is useful. So I'm going to copy and paste this here. We can also enforce it to make sure the position component is there. The speed is going to be, yeah, let's just put that, that should be fine. Speed, and an update, by the way, is called every 1/60 of a second, which is roughly 0.016 and then 6 recurring. So we're going to translate y speed. So that should every every frame translate our position or position of the droplet. And don't forget to actually add the control. Now if we run this, we should see them moving as soon as they spawn. Yep. Finally, we need to be able to catch those things using our bucket. And for that, we will use a collision system. So first of all, we need to add a bounding box for each of our entities that we need to collide, which you can do either manually or just put a comma and then say true in set view, which is a hint to main view component to try and create a bounding box out of the view that it's been passed. So we'll take the image in as a texture and we'll create a bounding box around the texture, which is very useful if you want just a rough estimate of the bounding box. And the bounding box created will use rectangular bounds, so the shape is going to be either a square or a rectangle based on the texture size. So with this would have created the bounding box. Now we need to add a component called collidable and set its flag to true. This is a hint to the physics engine that we need this entity to be collidable, so it will participate in collision detection or collision checking. Finally, we'll come back here in init physics. We obtain reference to our physics world, which hasn't been doing anything so far. And then we say we need a collision handler between certain types. And those types I haven't yet defined, so I'll just go back to Industry Factory and create some types. Types are typically enums, and most of methods will expect the type to be an enum. So I'm going to create an enum entity type. There are literally just two types, so I'm going to create droplet and bucket. You can attach type by just obtaining type component, set value, and then passing in the type, which is droplet. Same for bucket, except it's bucket type. Now that they have types, we can easily do detection or collision detection between the items or entities. Physics world, add collision handler, new collision handler, and again, you'll be prompted to override, well, yeah, for methods. What you want is on collision begin, because this will happen immediately when there is a collision. The rest happen exactly like the action part. So on collision happens if they're still colliding. On collision end happens when the collision is no longer present. What we want is collision begin. collision handler takes two types, which is exactly what we need. So entity type droplet and entity type bucket. Now, I might have set them to be private. Yes, they should be public, so that we could see them in our application class. So yeah, I've created a collision handler between the type droplet and the type bucket. The order that you define your entity types is going to affect the order they are passed in to your method. So we've said droplet bucket, which means entities will be passed in as droplet and bucket to our collision begin method. And well, what do? We remove droplet from the world, and we can do so easily by just easily doing this. Droplet remove from world. And since we don't really have any user interface, and which is probably beyond the scope of this tutorial, I'm just going to print stuff to this to the command line. Droplets, we'll say just caught droplet. That should do. And I'm also going to move the height of the bucket slightly, rather y direction slightly up, so that we could see droplet being caught or being sort of taken from the world, removed from the world. And since we've registered a collision handler, that should be pretty much it, and should now all magically work, hopefully. Yep, seems to be working. So we're catching those things. That thing is being printed out to the command line. The collision detection is based on pretty much access aligned bounding boxes, which are created from the view. If you want a bit more sort of realistic collision detection, then you will need to use an actual physics engine, which is part of FXGL as well. It is the JBox 2D engine, which has been integrated successfully. And yeah, so that is pretty much it for the game that we just created. And just to test, I'm going to go back and there we go. We're going to type maven package. Which will have created that executable jar, which we can just double click, and it should just work straight away. So with just one command, you can easily package FXGL games. And actually, I've forgotten to use sounds, so which are actually quite easy. Just instead of caught droplet, I could use get audio player, play. So you can play music same way you could play sound. So I'm just going to do sound, which takes either a sound or name of the file, which is drop WAV. And I'm going to just increase slightly because it's taken directly from the sound is recorded directly from the audio part, so it's kind of loud, maybe loud for you in the video. Yeah, so it seems to be working. Just going to disable this now because it's probably loud. Yeah, so that is working. You can play your music in the same way. You'll need to probably load it as a music and then set a number of times to play more than one, so that's looping. I'm just trying to remember if there's anything else I should cover. There isn't any cleaning up that we need to do. Everything's done by FXGL and exit, so don't worry about that. Pausing and resuming, again, automatically done when you enable menus. So yeah, that should be it. Next thing I'm going to point out is this is the base repository of FXGL itself. This is how you can get it by a maven. This is how you can get it by a Gradle. And this repository that we looked at earlier, FXGL games, contains some game samples that you could use, and you could look at the code of, so you could easily integrate some stuff into your own projects. Finally, in the original FXGL repository, if you go to samples, you will see a decent list of various features implemented in a sample. So for example, if we do a game window, you can see sample, which is quite short. It only features the bit that you actually need to get this working. So this will create a game window if you want to. And that is, I think, truly it. Yeah, thanks for watching.